In Activity 9, Making a Magnet, students first demonstrate how certain materials can be turned into temporary magnets. Students then observe how temporary magnetism is lost or weakened. You will need the following materials from the kit: large magnets, magnetic rods, iron nails, paper clips, white paper sheets, and iron filings. You will also need to provide safety goggles. To prepare for the activity, each group of 2 students will need a rod magnet, a paper clip, a large magnet, an iron nail, a sheet of white paper, and about a teaspoon of iron filings. To begin the activity, divide the class into teams of 2 and distribute the materials. Then, distribute a pair of safety goggles to each student for use when working with iron filings. Next, tell the students to bring the nail near the paper clip and observe what happens. Then tell them to bring the rod magnet near the paper clip and observe what happens. Ask students, which of these items demonstrated magnetic force? Students will find that only the magnet has magnetic force because it was able to pick up the paper clip. Next, have the students attach the head of the nail to one end of the rod magnet. Now tell them to bring the pointed end of the nail near the paper clip. Ask students, now does the nail have magnetic force? Students will see that the nail picked up the paper clip, so it must have magnetic force. Then ask, where did the magnetic force come from? The magnetic force came from the rod magnet. Next, tell the students to pick up a paper clip again. While the paper clip is hanging from the tip of the nail, tell them to remove the rod magnet from the nail and observe what happens. Ask students, does the nail still act like a magnet? Students will find that when the magnet is removed from the nail, the paper clip falls. Explain to the students that this experiment demonstrates temporary magnetism. The iron nail was temporarily magnetized when it was touching the magnet. When the magnet was removed from the nail lost its magnetism. Explain further that because the atoms in the iron nail are situated randomly throughout the material, the nail exhibits no overall magnetic force. But when the nail is brought into the magnetic field of a magnet, the atoms in the nail align, producing a temporary magnet. Walk around the classroom and sprinkle about a teaspoon of iron filings on a sheet of white paper for each team. Have the students try to pick up the iron filings, first with the rod magnet, then with the nail. Make sure students wear safety goggles to avoid getting the iron filings in their eyes. Suggest that they use a pencil to brush the filings off the magnet. Have students wash their hands if they handle any filings. Then ask students, does the magnet pick up the filings? Does the nail? Is the nail magnetized? Students will find that the magnet picks up the filings, but the nail does not, because it is not magnetized. Demonstrate how to stroke the nail with the magnet. Hold the iron nail at one end and drag one of the flat sides of the magnet down the nail from head to point. Make sure to move the magnet in a large semicircle away from the nail's point and back to the head again. Stroke the nail in this manner 10 to 20 times. Remember, if the magnet is not moved away from the nail after each stroke, the atoms inside the nail will not stay aligned and the nail will be difficult to magnetize. Next, tell the teams to stroke the nail with the large magnet 20 times and to then try to use the nail to pick up the iron filings. Students should be able to pick up quite a few filings after 20 strokes. Then ask students, what do you think happens to the nail to make it become magnetized? Explain to the students that stroking an iron nail with a magnet aligns the atoms in the nail so that the nail becomes a magnet. Finally, have the students drop their nails on the floor, pick them up, and test them again to see if they can still pick up the iron filings. Students should notice that the magnetic force of the nail has been weakened. Point out that dropping the nail knocks the atoms back out of alignment, which decreases the magnetic force of the nail. To conclude the activity, pick up the sheets of paper and pour the iron filings back into the container. Return the materials to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.